The ligament's going to hold the joint together, keep it from being sloppy and moving around too much. All right, so you remember when we were doing your only 5-minute neural thing, you do the joint position test. Okay, there's nerve endings in the ligaments, and they're going to pick up information as far as is the joint moving, which direction is it moving, what speed is it moving at, and it's like proprioception. So one of the things that you do for rehabbing joints, like let's say somebody has a tendency to, they're spraining their ankle a lot, so their ankle's rolling out like that. So then you do exercises on a wobble board, right? People have seen that, right, where you're balancing. You can either have one that's 2 dimensions where it goes back and forth like that, or you can have one that's a circle on the bottom so it goes all in different directions. Because the idea is what you want to do is you want your ligaments to develop that nerve pathway back and forth so that they're more sensitive to the joint position so they can react quicker. So if your ankle starts to go, your body's going to pull it back. So it's like a reflex loop. You know, you have the nerve endings in the ligaments. It senses that the joint's starting to move, goes up to the spine, and then back down quick to the muscles to pull it back so that you don't sprain your ankle. So when the forces exceed the strength of the ligament, then it's going to tear. Right? And then what kind of injury do you call it when you tear a ligament? Sprain. Right? And then what's a strain? Muscle or tendon. Yeah. Right, so then you have the bursa, which is again is part of the inert tissue. And basically what that is it's a fluid-filled sac that's usually in and around joints or tendons, and it gives lubricates the joint so that it reduces the effects of friction on the joint. And then sometimes you'll have a synovium or kind of like a bursa that surrounds a joint, a tendon. And like in the tendons of the hand and finger, there's different sheaths of like a bursa sac that the tendons go through to keep them lubricated and moving smoothly. Then the other type of connective tissue that you have is the fascia. Okay? So in a sense, you can think of there's a plane of fascia that pretty much transmits all throughout the body. You have different planes of fascia where there's different techniques that people do as far as like golfing or things like that, where they work with the fascia, how it interconnects. And when you talk about anatomy, there's certain, like you have the anterior compartment, things in the leg where the fascia is continuous along the side, and then you have the tensor fasciae lata, which is a muscle that goes into the tendinous band that goes along the side of the leg, but it's also contiguous with sheets of fascia that surround the anatomy. It surrounds all the muscles. Okay, so you can do different stretching and things. People can have tightness of their fascia, and you don't really hear of injuries like where you say, "Oh, I just tore my fascia," But you can have iliotibial band tendinitis and tight iliotibial band or something, but that's like a localized, specific part of fascia. But you can understand how it's sort of continuous through the body. You have different connective tissue planes that intertwine different parts of the body. So that's basically the inert tissue. So what are the things that we talked about that is made up of? That's inert tissue. Yes, you have bones. Cartilage, ligaments, joint capsule, bursa. Okay. Basically, it's tissue that just sits there that doesn't generate its own forces. It reacts to force, but it doesn't generate any contractile. So it's more passive. It's inert tissue as opposed to active, which would be contractile tissues. So that's going to be basically muscles and tendons and where they attach. What's that?
The tendons?
Yeah, the tendons are going to attach the muscles to the bones. And that's going to be dense, regular connective tissue again. So you're going to have fibers that line up along the lines of force. So tendons are basically like ropes. And it's mostly going to be collagen fibers because you don't want that much elasticity. When the muscle pulls, you want it to act as a direct force. You don't want it to stretch. So it's going to be mostly the wider collagen fibers. And it's going to help to produce movement. Right, so we're talking about contractile tissues that are going to be active, that are providing movement. And then the types of injuries that you're going to have is going to be tendinitis, tendinosis. Again, another thing, the term is tendinitis you hear a lot, which means inflammation, but more often it's usually better to use the term tendinopathy or tendinosis, because there may not be inflammation, but there may be damage to the tissue, but it's not inflamed. So you'll hear tendinitis, tendinosis, tendinopathy, things like that. And then you're going to have Golgi tendon organs, which are sensory nerve endings that are in the tendon that sense stretch of the muscle or tendon. They measure the force. Because that's basically part of the thing that you do when you're doing a deep tendon reflex. Okay? You're tapping on that tendon, and what it's doing is it's giving it a short little stretch, and those Golgi tendon organs pick up that change in tension on the tendon, goes to the spinal cord, sends back the nerve impulse to the muscle to make the muscle contract. So again, muscles are going to be, we're talking about skeletal muscles, which are voluntary, and those are going to develop tension or force. That's what moves the body. Okay? And you have what's called, you can have muscles that are used to produce movement and activity, but also, for me to be standing here, I'm going to have some muscle contraction that's going to hold my posture upright. Otherwise, it'll just flop into a big pile of muscle. Right? So it's going to maintain upright posture. Right? So there's certain muscles like your soleus and other muscles that have to do with maintaining your upright posture. And then also it's going to help the body to absorb shock. Right? And then there's basic properties that muscle has, is that it has ability to stretch and come back. Right? So it has elasticity to it. And then also extensibility. So it can be stretched, but it comes back to its original length. And then irritability or contractility, meaning that it can respond to a stimulus and it contracts. Okay? So we're talking about contractile tissue. So the muscle is going to contract, and then also the tendon's part of that because it's what produces motion. So then you have different types of muscle contractions. But do you understand the difference between isotonic and isometric? Well, what does the word iso mean?
Equal.
Equal. And then metric
Measurement.
would be measurement or length, all right? So isometric is where the muscle doesn't change in length. That'd be like this. Okay? Isometric. Versus isotonic, which would mean basically the tension in the muscle stays the same. But the thing is that isotonic is that the muscle either lengthens or contracts or shortens while it contracts. So you have two different types of things. Concentric is where the muscle shortens as it contracts, and then eccentric is when it lengthens as it contracts. Like if I'm holding up a weight, I'm lifting something, I have to have tension in my biceps to hold it up, but it's also lengthening as I go down. So that's an eccentric contraction, and this is concentric.
So you said isotonic is length and a contraction?
A change in length when the muscle contracts. Isometric is the length stays the same. Isotonic is the length changes. And then you have different terms when you're talking about muscle. You have the agonist or the prime mover. When you have a certain movement that occurs, there are certain muscles that are the main ones responsible for that action. Okay, so those are going to be prime movers. And then you're going to have an antagonist, which is the muscle that does the opposite action. So if I'm moving my arm like this, what would be the prime movers? Biceps and brachialis. Okay, and then what would be the antagonists? Triceps. Okay. And then stabilizers are other muscles that facilitate an action by stabilizing something. For me to move my arm around, I need to have my scapula held in place. So then there's a lot of muscles that can stabilize and hold the scapula while the arm is moving.